Hello! Today we are going to do chapter 9.2, which is solving quadratic equations by graphing, and this is our second method of solving a quadratic. So the first method we've used several times is the zero product property that involves setting a quadratic equal to 0, factoring, and then setting the factors equal to 0. There are 5 methods total for how to solve a quadratic, so this is method number 2, solving by graphing, and it just includes graphing the quadratic. That's it. So we're going to start out on page 283 of your journal. And our first discussion is going to be on where is a solution and how many solutions might there be. So when you graph a quadratic, you get what's called a parabola. So here I have 3 examples of parabolas. So where are the solutions? The solutions are your x-intercepts. That is where the solutions are. They are your x-intercepts. So notice in the first picture, we have 2 x-intercepts. You'd actually say the answers are x equals -3 and x equals 2. There's 2 answers. So it is going to have 2 real solutions if it crosses the x-axis in 2 places. Okay. The second one only has 1 x-intercept. There we go. That is at x equals 1. And so it is going to have 1 real solution if it has 1 x-intercept. That is because, and you might have heard me say this word before, that is a double root that actually counts as 2, and it's because it bounces off the x-axis. And the third one over here never crosses the x-axis, and so it is going to have no real solutions. There are solutions, they are imaginary, but at the moment we're just going to say there's no real if it does not ever cross the x-axis. So going back in our journals to page 257, part that we skipped out of chapter 8, because we just did a quick overview, is that how to find the axis of symmetry of a parabola. So every parabola has an axis of symmetry. It's the center line. If you were to fold it on that line, the parabola would line up. And the axis of symmetry goes through the vertex. So I bring this up because when you are graphing, sometimes it's nice to know where the middle of the parabola is. So I need you to know this equation right here. That's the equation for the axis of symmetry. So where do we get A, B, and C from? Actually, just A and B. A and B come from our quadratic equation. We are going to need to make sure the quadratic equation equals 0 before we get A and B. That gives us the axis of symmetry, and then the axis of symmetry gives us the x of the vertex because they are the same thing. The x of the vertex is that same thing as the axis of symmetry. And then another little just helpful tidbit is your c value, which is your constant. Has nothing to do with the fact that that's why it's a c. That is the y-intercept. Okay, so if x in both cases is 0, all you're left with is c, and then c turns out to be your y-intercept. And it's just a nice point, just a really quick point to have. So we're going to graph. I think I have 3 of them up for us to graph today. And we're going to solve by graphing, which means our ultimate goal is what does x equal? Before we get to graphing, here's going to be your steps. Step number 1 is I want you to make sure that your equation is in the form ax squared plus bx plus c equals 0. So that means setting it equal to 0 and making sure the non-zero side is in descending order. Then you're going to graph, okay, and that's pretty broad here. We're going to graph by first finding our axis of symmetry, and then after that we're going to make a table. So we're going to graph, and we're going to graph until we find our x-intercepts, and those are our answers. And they are also, though, called the solutions or the roots, or they're also called the zeros. So one thing that has so many answers. All right, so let's see what that looks like. We're going to start with number 1, and number 1 is x squared plus 4x equals 0. So notice it's equal to 0, And if we're looking at ax squared plus bx plus c equals 0, we're going to see that a is 1 because there's 1 x squared here, and that b is 4, right, because b is what's in front of the x. So when you do your axis of symmetry, which I'm going to abbreviate AOS is my axis of symmetry, your equation is x equals negative b over 2a. So x is going to equal negative 4 over 2 times 1, or just 2, which is negative 2. That is your axis of symmetry. What that means is that there's this invisible line right here, in which case if my parabola is centered there. If I folded my parabola, it would line up on either side of that line. So my vertex has to be on that line. So I'm going to start my table. That's number 2 on my list of things I said. And personally, I'm going to put negative 2 in the middle of my table. You don't have to, okay? I'm going to put negative 2 in the middle of my table. And then I'm going to put negative 2 in for both of these x's. So you might have a calculator handy. I'm going to do negative 2 squared plus 4 times negative 2, which is 4 minus 8, which is negative 4. So at negative 2, I'm at negative 4. So I have that point right there. Your goal is to get to the x-axis. Those are your answers. Okay, so I put negative 2 in the middle of my table so I can kind of work on both sides. So I'm going to do negative 1 next. So I'm going to put negative 1 in for both of those x's. Negative 1 squared is a positive 1 minus 4, and that's a negative 3. So at negative 1, I'm at negative 3. So I'm going to go ahead, oops, wrong button here. I'm going to go ahead and keep working on the right side. And up next, I'm going to put in 0. So I have 0 squared plus 4 times 0. So that's 0 plus 0, which happens to be 0. That point is on the x-axis. That's the point I'm looking for. Okay? Based off of symmetry, I'm 2 to the right of the axis of symmetry. So my other 0 should be 2 to the left, which would be at negative 4. Okay? Instead of assuming it's at negative 4, because I see this all the time that we assume one thing and it's wrong, I'm going to come down here. I'm actually going to try negative 4. I'm going to put negative 4 in for both of those x's. And I'm going to get 16 minus 16, which is 0. Perfect. So at negative 4, I'm at 0. So you might notice I only graphed 4 points, and that's fine. The whole purpose here is just to find where it crosses the x-axis. So as soon as you've done that, you're pretty much done. You are going to make sure to draw in your parabola, because it's going to say solve by graphing, so we want to make sure it's graphed. And then we're going to need to provide our answers, and our answers are what are your x-intercepts, and they're negative 4 and 0. Those are your answers. The rest of it is work. Okay, so quick overview. We found our axis of symmetry first. That's what we started with, the middle of our table, and then we just made a table until we found our x-intercepts. All right, we're going to do that process again, but you might notice that this time our equation does not start equal to 0, so we're going to need to move some stuff. So you have two options. You can move the x squared over to the right, or you can move your 2x minus 6 over to the left. Now personally, I'm a move the 2x minus 6 over to the left type of person. You need to know it does not matter which way you move things, okay? You will get the same answers either way, I promise you. Okay, so I'm going to subtract the 2x from both sides and add the 6. So that's going to look like x squared minus 2x plus 6 equals 0. And that is my ax squared plus bx plus c. So a is going to be 1. It's what's in front of the x squared. B is going to be a negative 2. And c is going to be 6. And you don't need c. I just sometimes in the habit of writing that. So the first thing you're going to find is your axis of symmetry, which is x equals negative b over 2a. So you're going to get x equals a negative negative 2 over 2 times 1, which was just 2. So that's 2 over 2, which is 1. So your axis of symmetry is at 1. That means that's the center line of your parabola. If I fold my parabola, it's going to line up on that line. So when I start my table, I'm starting my table at 1. Okay? And I'm going to put 1 in for every x. And I'm using this up here. Okay, so I'm going to have 1 squared minus 2 times 1 plus 6. 1 minus 2 plus 6, that looks to be 5. So at 1, I'm at 5. So I think I'm about right there. Then I'm going to work on either side of that. So in this case, I'm actually going to work on the left, and I'm going to look at 0. Okay, and if you remember too what I said 2 slides ago, that the constant is always your your constant is your y-intercept. So my constant here is 6, and that should be my y-intercept. And if I look and I put in 0 squared minus 2 times 0 plus 6, that is 0 minus 0 plus 6, which is 6. So my y-intercept is 6. Now I'm actually going to go over to 2. And I'm going to plug in 2 here real quick. 2 squared minus 2 times 2 plus 6. So that's 4 minus 4 plus 6. That is 6. Well, which way is my parabola opening? My parabola is opening up. Now, if you remember from the Chapter 8 video, you should have known the parabola was going to open up because your leading coefficient is positive. Now, if you happen to have been a person who wanted to move your x squared over to the other side, your parabola would actually open down, but your vertex would not have been up here. Your vertex would have been down here. All right, so this parabola does open up. This is what your parabola looks like up here. Is that ever, I can draw a better parabola, is that ever going to cross the x-axis? No. So your answer is no real solution because that is not ever going to cross the x-axis. All right, and our last example for the day. So first of all, make sure it's equal to 0. Then you need your A and your B, and maybe your C if you just want to practice. So what's your A? 1. B is negative 10. Remember your axis of symmetry is x equals negative b over 2a. Write that equation often. That's the way you remember things. So a negative 10 is a positive 10 over 2 is going to be 5. So your axis of symmetry is x equals 5. Okay. That's where you're going to start your table, is at 5. So if I plug in 5 for both of my x's, 5 squared minus 10 times 5 plus 25 is going to be 25 minus 50 plus 25. So what do we think that is? It looks like 0 to me. So at 5, you're at 0. You're already on an x-intercept. All right. So if it says solve by graphing, you must fully graph it. So we need to do something else. So I'm going to jump to 4 and see where 4 puts me. So I'm going to have 4 squared minus 10 times 4 plus 25. So that's 16 minus 40 plus 25. All right, that looks like 1. So at 4, we're at 1. So really, if I do 6, we should be back at 1 because of symmetry. I'm going to try that just in case. I'm going to do 6 squared minus 10 times 6 plus 25. So 36 minus 60 plus 25. That is also 1. So at 6, I'm at 1. So my parabola is right here. All right, so we didn't technically like cross the x-axis, but we are on the x-axis. So that is our answer. Our answer is x equals 5. And this time there's only one answer because that is a double root. All right. That's what I have for you for this lesson. Please let me know if you have questions. Okay, I'll be live this week to help you out. Take care.